Okay, welcome to CS170 for the spring session. As you know, we'll be doing this virtually until at least the end of this month, so we'll see what happens from there. If there's any questions or whatnot, feel free, just pop in there and just let me know. For those of you that may not have seen the message, we are recording this, so this will be out there. We'll post it out to Canvas. I believe actually I am going to record all of the lectures as we do them. So for this whole semester, we'll have recordings of the lectures out there. So yeah, I'm just going to start to just give you a quick intro about CS170. And we'll see where we go from there. Okay. All right. So if you haven't gone to Canvas, let me go there actually. So if you go into Canvas, this is the home screen. You can see here, there's a couple of different options. You'll see things like announcements, assignments, files, grades, and whatnot. You'll click on those. I know sometimes people have talked about them being a little bit confusing. You have to click through all these different things. So we tried to make it in a couple places kind of just in one place. So we kind of said, here's course information. You can have like your syllabus and your schedule and all that kind of stuff. You can click through here. And then you can see here, you have your exam schedule. And you'll see synchronous lecture, asynchronous lecture. You folks that are on with me right now, you're right here. So this is over at Voorhees on Tuesday and Thursday when we're running face-to-face. And if you click through on this, this is my section here. So you'll see I kind of provided the same thing. I have my email here. You can click through a class announcements, the student schedule, the assignments. Each week I have modules that have resources. Could be reading material or whatnot, practice exams and stuff like that, quizzes and exams. And we have our labs and office hours, which we published. Office hours won't be until next week, but I'll show you that in a second. And then I'll have like this little table here, which I'm going to put in each week, the PowerPoints and the recordings and stuff like that for the lectures. Let me see here. So let me just click on office hours while I'm here. So you can see every day we have lab hours at various locations. Of course, everything for now is virtual, but you have all of this. This is the schedule. And then here's the office hours. So all the TAs, you can go to any of these lab hours. Okay, so it doesn't matter whether it's your TA or your section or whatever, it doesn't matter. We're all working on the same assignments and whatnot, so you can pop into any of these. For myself, so here's the lecture instructors here. For myself, I've kind of reserved at the same room that we give the lecture. So every Tuesday and Thursday, right after class, I'm just going to stick around for an hour to basically hold my office hours. So I'll be around to help you with any topics that you have questions on. As we get into the assignments, I'm sure some of you are going to want to, have some troubleshooting sessions or whatever. I can help with that. So I'll be doing that right after class for myself. Okay. So let me see here. I'll close this up. I'll come back to this in a little bit. I'll come back to the PowerPoint for now. Yeah, so again, here's my email. I'm pretty responsive on my email. So if you send me something, I'll get back to you fairly quickly. During the day, I actually have a full-time job. This is not my normal job. This is something I kind of do on the side. So if I'm in meetings or whatever, I might not get back to you until end of day, but usually I'll respond to all my emails within the same day. Okay. And if these office hours don't work for you, just give me enough notice and we can do something by appointment also. Okay. So we just go through a couple common things that we cover for this class usually. So who am I and why am I teaching this class? So I actually graduated from Rutgers many years ago, computer science actually. And then I got my MBA over at NYU Stern. And I've been working in investment banking technology for quite a number of years now. I've also started up a few different businesses. I run asset management for a couple of areas. I also handle real estate investments, and I'm teaching this class. This class is kind of an extension of something I started doing a while ago because I was heading up campus recruiting for my team here on campus. And then there was an opportunity for me to do some teaching here. So I decided to kind of pick that up. Sort of like my giving back as an alumni here at Rutgers. So, basically I work here, I contribute my salary to the Rutgers scholarship. So technically, I guess I don't get paid for teaching here. It's for the scholarship for Rutgers SAS. But basically, it's something that I feel like Rutgers has a great setup in terms of like proximity to New York, as well as New Jersey. There's a lot of big companies here. Actually, my son is actually going to Rutgers right now, so I'm a big fan of Rutgers, and I enjoy teaching what I'm teaching right now. So that's why I'm here. So why are you taking this class? Well, I guess for one, you guys are required to take this class. But, I know some people are kind of saying, oh, I'm never going to apply this for my future, whatever my career path takes me in the business school. And that may well be true. Okay. But the truth is, I think in this day and age, we have to be usually pretty proficient with technology in some shape or form, right? So, I think almost every sort of analysis that we're going to do is going to be some variation of Excel spreadsheets. So there's that aspect of things, and it's at different scales too. So, big data is obviously a common thing, right? Right now, with the way technology is, it's really a huge amount of data out there. So whether we're looking at things in terms of marketing, in terms of sales, in terms of like how we do analysis on the performance of various businesses, we're just inundated with data. And, being able to manage that, being able to manipulate that on your own is going to probably be a fairly important thing for you to do. So, the actual languages we may use may not be what you might use. You may not be using JavaScript, HTML. You may not be creating your own website. You may not be running your own e-commerce setup, but you may be. But you might be doing stuff with Python, might be doing stuff with R to pull in a lot of data and, maybe Jupyter notebooks to be able to do a lot of analysis on big data. And so some of these concepts on how we, define algorithms to process, data or, user experience on the e-commerce site, all of that is in common in terms of what we're trying to show here. It may not be 100% like exactly what language you might be using from a technology perspective. And, like I said, maybe you're not going to have to use this ever in your future. But, if every class you took at Rutgers was something practical that you would be applying for whatever your future career may be, maybe you shouldn't be at Rutgers. Maybe you would be at a vocational school, right? So there's a lot of classes at Rutgers that, you're more learning certain types of thinking, how to approach problem solving, how to meet deadlines, so on and so forth. So that's my little spiel on why are you taking this class. I would say from a practical standpoint, Excel is probably the most common thing that you're going to be using no matter what you're doing in your future careers, okay? So that's kind of one of those things I hope you get out of this class. Number one, being able to understand like some principles about technology and how they fit into how we do business, whether you're working in a corporate environment, whether you're running your own business, whether you're just doing some analysis on whatever problems you might be trying to solve. Technology usually has a role in that somewhere, and being technology proficient is going to help you to be successful, whatever you're going to do in the future. Okay. So how do you succeed in this class? So I would say a couple of things, and I usually say this for every semester. You have like, obviously because this is a required class, you have a lot of students, right? But this is not one of those classes that's meant to be like a weed out class to kind of fail people out. That's just not going to happen. Like I would say roughly, at least the sections that I've been teaching over the past years, 90% of the students in this class will get a good grade, which is like an A or a B, I think. And then out of those 90%, actually 90% of them actually get A's in this class. So to me, there is work to be done in this class. As long as you do that work, you'll get a good grade in this class. There's a lot of things that we do to help you to be successful in this class. And I'll walk through that as we go through some of the stuff for this class. But the main thing here is that I think we provide a lot of the opportunity for you to be successful in this class, but it's a two-way street, right? You have to put some effort into it. And, you know, we all recognize, especially in the current situation, there could be some challenges. It could be health challenges. It could be logistics challenges, whatever it may be. The only thing I would ask is that if you encounter a challenge or an issue, that you let us know as soon as possible. If you tell us like at the end of the semester that you couldn't turn in your assignments because of like some health issues, it's a bit late to tell us something like that because there's not much we can do at that point. But if you tell us as soon as possible, we can do things like, you know, maybe schedule like a different assignment or whatever. Like we have more options if you tell us about your challenges sooner rather than later. We get into all kinds of issues when you tell us pretty much the last day of class about why you couldn't get your assignments in. So do give us a lot of heads up as much as you can, and we'll do our best to work with you, okay? So to me, you put in some effort and you should do well in this class, okay? How do all the pieces fit together? So in case you may or may not know, there's different people here. It's not just me, right? So I happen to be giving the lectures here 2 days a week. And you know, you also have TAs, teaching assistants. And they're the ones that really, number one, they're actually the ones that are grading your assignments. They're the ones that are actually grading your exams. So do I get involved with it? I get involved with it if there's a disagreement. If you don't agree with how the grading has been done, or you had some other issue, I'm here to facilitate, right? So, but my main job here is to give the lectures. You know, like I said, I do have a day job, so it's not like I'm sitting around during the day to grade exams or do other things during the day. That's what we pay the teaching assistants for. Okay, so if you have questions on that, we do give out the assignments, you know, at least a couple weeks in advance. And a lot of times, you know, it's not like in class or in the recitations, we're teaching line for line exactly what you're going to do on the assignment, right? We're going to teach the basic ideas and principles, and then you're supposed to translate that and apply that to the assignment. But at the same time, since we provide the assignments a couple weeks in advance, you probably want to get in there and look at the assignment fairly early on and say, hey, I have no idea what this is. And then ask your TA, go to the lab hours or you can talk to me after class and we can help you. You can't really go like 5 minutes before the assignment is due and then ask us questions at that point. It's a bit late to ask us questions. So again, this is another one of those things that if you want to be successful in this class, do try to take a peek at the assignments that are coming up when they open up. And if you have questions, just reach out, drop into lab hours, drop in to the office hours, whatever, or even ask questions during class, okay? And some people have asked me, do we take attendance? Yes, is the short answer. And so does that mean like if you don't show up for class, like we're gonna give you like a failing grade? Not necessarily, but it's more like you show up. Number one, it helps you because it helps you to be successful with the assignments or the exams. But number two, there is a decent amount of extra credit for this class. So for me, I'll ask certain things during class. It's sort of like questions or whatever, and you do submissions off of that. One, I hope that helps you to study, but number two, that's what I use for my extra credit. And the TAs are doing something kind of similar in terms of using attendance in some shape or form to give you extra credit. Those extra credit, usually at the end of every semester, is usually enough to push you up about half a grade, right? So that's the difference between a B+ and an A, or a B and a B+. So do be mindful. I don't think our extra credit is particularly hard. Some of the extra credit is just kind of showing up. That's kind of, hopefully that answers the idea of do we take attendance? So that's how we do it. We take the attendance in some informal way, maybe doing proms or whatever. But then you get extra credit, and those extra credit could swing your grade by half a grade at the end of the semester. Okay. Some people have asked me, do I do recommendations? I do recommendations, especially since I'm not the captain of the recruiting team here at Rutgers for my company anymore, but I'm still on the recruiting team. So I do recommendations, but again, I don't really just write a recommendation without knowing you. So it would be helpful if you want a recommendation from me to, kind of introduce yourself, talk to me a little bit, share with me a couple pieces of like your background, your work, and so on and so forth. And I'd be happy to write a recommendation for you, whether it's for internship, a regular job, or if you're transferring to another school. So I've done that in the past. And again, I do have a pretty tight schedule, so I can't really turn a recommendation around like that quickly. If you can tell me with a certain amount of lead time, maybe a couple of weeks, then I can do something for you in a recommendation also, okay? Academic integrity, right? I know people kind of like moan and groan about the academic integrity stuff, but unfortunately, I have to say something about it because every single semester we get people flagged with academic integrity issues, right? And there's not really much reason for it either, right? Because I don't think the assignment or the work is that hard. So in case you don't know, right? So there are tools out there that does do a comparison of what you submitted electronically. All of the work for this class is electronic. It's not that hard to compare the work that you've submitted against what other students are submitting, as well as what is out there on the internet, okay? So you do want to be mindful of that. There's been different ways of handling it once we flag people. Now, to be clear, when you get flagged for academic integrity, it's an automated process. It's just a process that picks up work that looks very similar to either stuff on the internet or to other students. Then there is, I guess, what you call due process, right? Then we do have to do some investigation, whether it's the department head or whether it's some external folks that will be reviewing the evidence and then making a judgment off of that. Of course, input from yourselves also. I think for myself, I don't usually get involved with it. Sometimes I kind of get pulled into it if I have the time or people are asking for my help on it. Usually what I do when someone has code that's questionable, that about whether it's their work or not. So I'll usually schedule office hour with them and I have them write new code in front of me and be able to explain that code. Okay, so to me, if you're able to write the code and explain the code, then that kind of helps to alleviate some of the concerns about whether it's an academic integrity issue. So if you're in my class and you get flagged for academic integrity, that's probably how you're going to have to deal with it as part of this process. I would just recommend don't do it, right? It's a lot of work on our side to sort these out. It's not like we go through each one of these looking for people to have academic integrity issues. It's automatically done via like our code comparison tools. So just don't get picked up on that. And what we'll do is there will be guides, which I'll show you a little bit later, which will say, here's what you cannot do, right? Don't do this, don't do that. If you follow those guidelines, you'll usually be safe and don't have to worry about anything, okay? So anyway, I think I gave a pretty long introduction there, but hopefully this covers a lot of the common questions that I've seen over the last few semesters teaching this, okay? All right. So I have a screenshot here, but if I was on Canvas for the schedule, you can see it here. So you can see like the syllabus here. Do take time to read the syllabus. I don't really plan to go through exhaustive detail on the syllabus. I'm sure you can read the syllabus yourself. But let me look at the schedule here. It kind of pops up a little bit. And let me zoom this in. So you can see here, it's pretty standard, pretty well organized, I would say. So you have all the different weeks here. You have the week of, which is the exact dates. We have the topics that we plan to cover, the readings, right? Now the readings, some people say, oh, are you going to just cover everything from the book? If I was, then you wouldn't need to come to lecture. You could just read the book, right? So hopefully like all the different pieces that we have, they're meant to complement each other. So the book is one thing, you can read the book. In fact, a decent number of the exam questions essentially are coming right from the book, right? So it's almost word for word, some of these questions that we get for the exams and what's in the book, right? Whether it's the questions at the end of the chapter or some of the readings, it's right there. So the book is kind of important, and it is important for you to read it because I'm not going to cover it word for word in my lectures either. So I try to complement or extend what's being covered in the book for the lectures. And then as far as like detail working of like whether it's the JavaScript, HTML, or whatever, that should be covered in the recitations. Okay, so hopefully you can see how everything fits together. So you can see here's the recitation topics. So the recitation topics don't necessarily line up on the same week as the readings, right? And the topics from that. So that's why I'm trying to tell you they're kind of covering different areas, right? Now, just because the recitation says it's covering one thing, let's say this week, week 3, it's covering basic HTML, okay? And you can see it's covering the assignment, the basic HTML assignment is getting posted at the same time. Okay, now it doesn't necessarily 100% line up, but if you get it posted out and you look at it and you kind of see your TA is not exactly covering what is being covered in an assignment, you should raise your hand and let them know and say, hey, can you cover this? I don't really understand this and I need to know it for the assignment. So do make sure you keep that in mind. Okay, so don't wait until 2 weeks later to try to open up that assignment and say, oh, let me look at my notes from the recitation and then try to do it and then turn it in all like in one day or something like that. So like I said earlier, try to open up your assignment At least look at it. You don't have to do it, but at least open it up and then see if there's any questions that the TAs have not covered, and then make sure you ask those questions. That's what the TAs are there for, okay? So here's the posted date. That's when the assignments become visible, right? And here's the due dates. And then there's an accept until, right? So accept until means that you can still turn in the assignment late, but you only get half credit, okay? Now, the only exception to that is you get one free late every semester, okay? So for whatever reason, maybe you're sick or you just like were way too busy, you can tell your TA, tell your TA, because like I said, your TAs are doing your grading. Tell your TA that you need to exercise your free late, and then fine, you can turn it in late and you can still get full credit, okay? You have these quizzes here, okay? Now these quizzes here, again, they're meant to, they're not big exam type of thing, they're quizzes, right? They're meant to help you study for the real exams, right? You're gonna get 2 hourlies, you're gonna get a final. So they're fairly easy. You get 2 shots at getting these quizzes right. If whatever reason you miss these quizzes, we do open up all the quizzes at the end of the semester for a short period of time. So you can catch up on that and make up on those quizzes, right? And it seems like they're not that many points, but they add up, right? You add all these up, you know, they add up. So let's see, there's 5 on each one of these. So there's 1, 2, 3, 4, 5, 6, 7. That's 35 points right there. And I'll tell you, you gotta come down here so you can see like the total points here. Again, you're talking about almost like half a grade move there if you do your quizzes, which are fairly easy, right? Something to pay attention on these quizzes. But if you happen to miss the quizzes, like I said, at the end of the semester, we'll open it up. You can bang through the quizzes and hopefully we can catch you up there too. Here's the hourly exams, right? And then here's the points, right? You can see all the assignments with the points against them. Here's the quiz points, and then there's the exam points. And then for this week, usually there's like a lot of people coming in and out of the classes for the first week, so we kind of keep it light. So we have this extra credit, 2 points for the first week here, okay? So you can see here, introductory assignments, 2 extra credit type of thing. So you can work on that, okay? It's pretty straightforward, easy assignment, just 2 points extra credit, okay? That covers that, hopefully. All right, so that's your schedule. Again, syllabus, I'm not gonna go through the syllabus. The syllabus is actually pretty long, but do let me, I'll just kind of do a quick flyby on it. So let me see. Syllabus. Okay, so course table of contents. What I just talked about, the second chance policy, you might have seen that. This kind of talks a little bit about the logistics here. Recitations, here's the instructor info, the course objectives, right? Here's all your reading here. Here's all of the topics with the points next to them on the assignments. Academic integrity, do pay attention to this. So we have less people getting caught with this for the semester. So you can see all that here, blah, blah. Honor pledge. These are the Canvas tools I just kind of been going through. I'm not going to click through all of them. Okay. You might see this Piazza thing here. We've done it in the past. This semester, we agreed not to use it. So if you have questions or whatnot, just send the questions to your TAs. If they can't help you, then you can send them to me. This is your textbook. We have the electronic version, so you'll be able to access that online. Excel, all of the software stuff, that's standard stuff that that Rutgers has a site license for, right? So that's why you see Microsoft Office for Students, right? So it's for free. You can run the web version, but The desktop version is probably a little bit better because it has more features and whatnot. So when you submit your assignments, you can't just submit a link to a shared doc. You have to like do it into a local file, like a local doc or a local Excel sheet or whatever, and then submit that. Okay, do not submit a link to a shared document. Your TAs are not going to be able to pull that in. They're not going to be running through their grading scripts or anything like that. So just for that, just make sure you pay attention that you are downloading to a real file, local file, and then uploading that file into the Canvas website to submit for your assignments. Okay. I'll go through some of this stuff with the flowchart and the JavaScript stuff when we get into the class. So we'll get to that. The email. So email, don't try not to use a Canvas mail because I know a lot of the TAs don't look at it. I really don't look at it too much. So if you just send it to like the email I showed you at the front and your TAs are going to have their emails out there too, try to do that. Don't use the Canvas mail, please. Okay. Your grading, all your points, the grade distribution, all these points here. I will note, and I'm going to probably have to say it again later on, for the most part, the grade that you see in Canvas is pretty accurate until we get closer to the end of the semester. Because of what we have to do to support the second chance policy, your grades are going to kind of get a little bit distorted until we submit the final exam grades. So don't freak out and wonder why your grade dropped or something like that. But that's only near the end of the semester. So most of the time leading up to that point, your grades in Canvas will be accurate as the TAs are grading them and submitting your assignments. Okay, this is just an exam stuff here, makeup stuff, second chance policy. I'm not going to cover second chance policy today, but I'll cover it more when we get into the exam, or you can just read it here. Okay, quizzes, assignments, extra credit, computer labs. So it's pretty comprehensive, so do take the time to take a look at it. Okay. Grading, assignments, second chance policy. Here's the book again. Yeah, notice it says don't get the package. So there's some other extra complimentary package that goes with this. Don't worry about it, just get the book, okay? All right, so here we go, chapter 1, all right? So it's really, there's a couple ways to look at this class. One of them is kind of almost like a history class. I guess some of you either hate history or you don't, or you love history, I don't know. But you basically, you're kind of understanding certain facts, right? I like to look at like things not just as a series of facts, but understanding kind of the why, on why certain things came to be or how they hang together a little bit. But anyway, that's my thing, and I'll try to kind of point you in the right things to focus on and try to remember because it's going to be on the exam. Okay. And then it's just a matter of taking down those notes and just understanding it. Okay. So yeah, so this is talking about, okay, business and technology and how business and technology intersect. You know, that's the reason why we're taking this class again, right? So, you know, these are the main key ideas when you look at this introduction chapter. They talk about early computing machines and how that evolved into what you see today, whether it's like personal computers or desktop computers, and ultimately probably almost every one of you has a phone, and you know how that's really driving a lot of everything that we do today. All right, so this is just like early computing machines, right? You may recognize the thing in the back, this abacus. So yeah, it's early attempts to kind of make calculations easier, right? Of course, people did math and they did things on paper and whatnot. So these were like early tools that people developed to try to make their calculations faster or easier. Okay. So this is a notable person, Babbage. Yeah, you're going to probably get a question on him for the exam. So yeah, pay attention on this one, right? So recognize the name. I don't think you need to sit here and remember 1792 to 1871, but just recognize he's late 18th century, right? So this is the key part here, right? He's recognized father of the computer age, right? So we basically came up with these different things. Like I said, from here, you're looking for mechanisms to make calculations easier, right? And so that's what he was trying to get to. And that's what he developed. Here's one of his machines that's sitting in the Science Museum in London. Okay. And you can see here, right? Punch cards, like punch cards are like these cards with like little holes in them. I guess if you guys remember long enough ago, we had like these little dangling chads in the election, right? Punching holes in cards for voting and stuff like that, right? And so that kind of leads to this Herman Hollerith, right? So his big claim to fame is this whole idea of punch cards to digitize the processing of something that was very laborious, which is taking the census, right? So since the beginning of the United States, there's this idea of taking the census, right? And so up until this point in time, when he came around, this 1890 census, it was basically you collect all this information by hand. And so they came up with this mechanism to essentially use this punch card with all these holes punched in them to basically organize the data in a way that could be processed by a machine, right? You couldn't just like take a manual piece of paper, write information down, and then just say, okay, let the machine process it. The machine, there's no way in heck the machine's going to do anything with that. So that's what this Herman Hollerith's claim to fame is this automation of the census. And you can see the big difference, right? So the last time the census was taken before that was 1880. And it was, by the time they got done, it was practically time for the next census, right? It was like 8 years. So when 1890 came around, they just cranked through it in about a year, right? So that's like a huge difference. And especially like the population of the United States was growing. There's only so far you're going to get when you're processing this by hand. Okay, so this is an example of the punch card here, right? So you can see all these little holes there, and we'll talk about a little bit more when we get into like the binary system, presence and absence and all that kind of stuff, right? But the punch card is pretty key in the early days of computing. Just a picture of the machine. And yeah, here's zeros and ones, right? So when we talk about digitizing information, that's what this is, right? And so you can see these zeros and ones, and that's the language of the computer, right? So the computer is not going to be looking at the alphabetic system that we're used to. They're going to be looking at everything at zeros and ones. And as far as like how we map or translate between zeros and ones and what we understand, that's something that we'll be covering as part of this class. So we'll get to that. Okay. So early days, if you looked at the inside of computers and how they're processing, essentially processing the zeros and ones, off and on, essentially, it's vacuum tubes, right? So that's these big ginormous things here. And that because of the size of these things here, basically the early computers that are using vacuum tubes, number one, they generate a tremendous amount of heat. Number two, they basically take up the size of an entire building. So there's even some buildings that I've been to, like in New York, that used to be like switching centers for the phone company and stuff like that. they literally take up enough space to fill a skyscraper. So they're just ginormous buildings, enormous energy sucks, and heat sinks and everything is just unbelievable. So that's the early days of computing with the vacuum tubes. And you can see like these folks here, they're just like standing all around, dealing with the computer here. Okay, so when you can look, see these ladies here have all these things in their hands to kind of show you how big you're talking about here. And then it was a huge leap when you go into like transistors and integrated circuits, right? So you can see going from the top left here, going to bottom right, and even this is pretty old here. It's like a tremendous difference, right? To say that the power of technology, the computing power that you have in your hand right now on your phone is equivalent to what used to take up, several floors of a building. It's a pretty amazing leap there. Okay. Okay. So you can see here, this is going, you can still, it's by today's standards, like you can see like these little big knobby things here, they're still fairly big by today's standards, but by vacuum tube standards, it's a huge leap forward. Okay, and then you can see you're getting smaller and smaller over time, and you can see this here, right? So it's pulling more and more into a chip, basically, right? So that's the whole idea with integrated circuits, right? Instead of having like all this wire connecting different parts of a computer together, those pathways to connect them become more and more integrated, smaller and smaller, to the point where basically you can do the entire functionality of the computer all in like one chip. Yeah, so this goes more into the integrated circuits, and you can see now it's like, smaller and smaller like that. All right, so that's on the hardware side, essentially the computing chip side of things. Now there's another aspect of this, and so just understand like this flow from the vacuum tubes down to the integrated circuit. Again, that's also going to be a part of your exam. Okay, personal computers. All right, so key part of all of this is the whole idea of like, how does computing become accessible to quote unquote the common person, the regular person, right? For a long time, a lot of this stuff is like basically just a whole bunch of numbers, punch cards, text-based screens, then it's going to be mostly in the hands of like mathematicians, scientists, computer science people and stuff like that. It would never really be appealing to quote unquote normal people, like retail, like regular people, right? And so part of the evolution to make it more of a mass market type of appeal and more usable by the wider population is the idea of the graphical user interface, right? And so this is an early 70s type of thing, and Xerox is a big name in this space with this initial introduction here. And you can see, this is like maybe the first thoughts of the personal computing, right? I know it doesn't look too personal, but this is the way things were back in the 70s, which is still a big leap from where we were before. Okay, but here's the real breakthrough: is things like Apple, and to a certain extent the IBM PC, like this, right? Of course, people will have some disagreement about like IBM versus Apple, but these two were the big players to really bringing computing to home use. Okay, so one thing to be careful, and we kind of get problems with this like every semester, with the idea of using like the mouse and the GUI, the idea of who invented it versus like who made it mainstream, right? So Apple did not invent a lot of things, right? But Apple made it so that it was basically commercialized, right? Commercialized for home use. So they made it popular. They made it applicable for home use, essentially, right? So do read the question carefully when this comes up in your exam as to like who invented the mouse, let's say, as well as who brought the mouse to mass market. So there's a distinction there, and a lot of people kind of mix that up when that comes up in an exam. So just pay attention and keep that in mind. We'll go more into these later in the class, but these are the main parts for the computer, right? So you have storage, right? Your memory, basically store whatever like files, your pictures, your sounds, whatever. Your input, right? Whatever you're inputting could be like your keyboard, could be your voice, right? You're inputting stuff through your voice. And then your computer, your CPU is basically processing all of these inputs, whether it's coming from like memory or it's coming from your input on your keyboard, doing something with it, and then it kicks it back out into an output device. Maybe it kicks it out to your screen. Maybe it kicks it out and sends it to another storage device, okay? So here's the distinction here, right? You see fully mechanical, that literally means like you have like gears or whatever running around. Abacus, like this is a slide rule, people don't know. You know, people are physically manipulating something, right? So that's like what these guys are on the left here, right? And then he kind of evolved things to the point where it's still hardware, but it's essentially digital, right? Meaning like there's no mechanical gears or mechanical aspects to it, right? It's all electric signals moving around to do the work of the computer, right? And then the personal computer, the personal is the key part there, right? It's really bringing the technology home so that regular people can use it, as opposed to like something in the domain of like engineers or you know, computer scientists or whatever, right? So this allows people, everyone, to be able to take advantage of the power of computing. Okay. These are, again, the different parts here. You can kind of read it. Don't get too caught up on exactly the details of all these different things. The main thing to think about is you have something that's the brain, right? It's doing some computing. You have something that stores information like memory or whatever. It could be local working memory. It could be, you know, remote storage or whatever. You can also have inputs. You have to be able to input something so that your computer can be useful. And of course, when the computer is done doing some work, it has to have some way to output the information, right? So this goes back to this other diagram here, okay? But there's like different parts here. So don't get caught up with this. This just kind of illustration here, gives you some idea, but you don't have to know too much more than that. Okay. Physical computing, yeah, it's just the hardware like we showed you back here. Okay, so that's physical side of things. And then you have the computing or the software side of things, right? So those are like the programs that we write to tell that hardware to do something useful that you care about. Otherwise, if you don't have the software, then you just have like, in this case, some plastic, right? It doesn't really do you much good at all. So the software is really what provides, in this case, algorithm is the important word here. What tells the hardware to do something useful for you as a user or a consumer. Yeah, don't worry about this for now. I'm going to go into it more a little bit later on, but basically this is what they call the software stack. Okay. Another concept for computing is this idea of abstraction, right? You can read this on your own, but let me give you like an analogy here that you might understand. So if you, I don't know if most of you drive a car, but let's say you drive a car, when you get in the car and you turn the steering wheel or you step on the brake, all you know is that the car turns or the car stops or whatever, right? You don't necessarily know, is the car drive-by-wire? You don't know like how all the different pieces go from the steering wheel or from the brake pedal to the relative parts of like let's say the brake pads on the wheels. You don't know and you don't care, right? So abstraction means like taking things up to a higher level that it's appropriate for whatever level it is. In your case, you're a user of the car. So all you care about is that you turn the wheel and the car turns and you step on the brake and the car stops, right? So that's what we call by abstraction. You don't care about the underlying details. Maybe your mechanic cares about the underlying details. And so that's the level that they're going to be at. They're not going to be at the same level as you as a driver of the car. Okay, so that's kind of the idea of abstraction. And it's an important concept for computer science because, you as a user of the computer, you're not going to be looking at the CPU. You're not going to be like operating at that level to get anything done for it. All you care about is like, you can download whatever game on your mobile phone and play around with it, or that you can make a phone call, or that you can send a message, whatever it is that you do on your phone. That's what you care about. So that's where the abstraction is. There's many layers in this stack here, right? Most of you are going to be at this top layer, at this application level here. All of this other stuff here, only a computer science person is going to care about this stuff for the most part. Okay, so that's the idea of these layers of abstraction. Okay, so that's the idea. If you have more questions about that, just let me know. But that's an important concept. Try to understand that. Algorithm, the simple way for me to describe an algorithm is basically think of it as a recipe, right? So you want to get some, in this case, a pizza brownie. Well, here's all the input, right? These are all the ingredients, right? It tells you exactly how much of these things that is your input. And then there's steps that you follow to put all these ingredients together to come up with your pizza brownie, okay? And that's exactly what an algorithm is for a computer. A computer has all these different inputs, and then it follows a process to take all these components or inputs, I should say, and produce a certain output, right? And so that's all what an algorithm is, okay? You can look at this saying it's precise and systematic, right? All that means is like a computer, like I said, a computer is looking at things in zeros and ones. It's looking at everything as digital, right? It's discrete. So you can't tell something like, oh, put in a pinch of salt or whatever. It's not very exact or precise, right? A computer wouldn't really be able to handle that for the most part. So you need to tell it exactly how much salt, let's say, in this case. And we're talking about a quarter teaspoon of salt, let's say. So, but that's the idea about an algorithm from a computer standpoint. This is a very like, I don't know, goofy type of algorithm type of thing, just to play around a little bit. Don't get too hung up on this. We'll go through like real flow chart and real algorithm in a later lecture. This is just the intro, so don't overthink this one. It's just for some fun here. Okay, and then just to summarize, right? So in this intro chapter, just the concept of what is hardware, what is software, a little bit of historical perspective, history, right? Introduction to the idea of software layers, which I was just talking about, and the idea of algorithms and abstraction. Okay, so I know I covered a lot of stuff and I talked through, many different things. Some of the things might have gone pretty fast for you, but have a think about it. Take a look at the book, read through that. Hopefully it's not too long of a reading or too hard of a reading. And then if there's any questions, feel free to send me an email, and I'm happy to clarify anything. Like I said, there's no office hours for this week. But if anyone needs to chat with me, just just let me know, pop me an email, and I'll just get back onto Zoom for this week. Next week will be office hours for me, so I'll stick around after the lecture. And then hopefully we're back in class in February. And then I'll follow up after class for any office hours, any questions that people have. Okay. So I'm going to stop the share for a second. Stop. Where's the stop here? Stop the share. Okay. Oh, and I see like there's a ton of stuff on the chat here. Okay. Yeah, all the slides are on Canvas. So, take a look at the slides there. Send me questions. And pay attention to your announcements, right? I post the announcements out there. So if there's anything that you need to know, do pay attention to those assignments to announcements on Canvas. Okay. All right. So other than that, looks good. Thank you for your first day of class. And, if there's anything, just shoot me a question and I'll answer you as quickly as I can. Okay. I'll see you guys on Thursday.
Thank you. Have a good night.
All right, good night.
Thank
Have a
you.
good one, Professor.
Thank you, Professor.
Have a good
Thank
one.
you.
Thank you.
Hey, Professor.
Rest of your day.
All right.
Hey, Professor, quick question.
Yes.
So, we do meet every day that we have class. We do meet on a Zoom call, correct? Because I noticed that the whole thing said like asynchronous schedule and synchronous schedule, and
Yeah.
I was.
Yeah. So our classes are synchronous for January. Synchronous means that Tuesday and Thursday, 7:30 to 8:30, I'll be running the Zoom. Professor Hajdu, he is doing what they call asynchronous. So that's kind of a different setup, but that's not what you guys are on right now.
Oh, okay, cool. So we're always going to be synchronous, and when we go back to class, we're always going to be meeting in class, right?
That's correct. And same thing
Okay,
for your
cool.
same thing for your recitations.
Oh, all right. Thank God, because I get so scared with asynchronous because I don't really have anyone around me to help me out. So I'm
Yeah.
always more used to the synchronous classes and stuff. And also, given an introduction to the course, you mentioned that it was more of a historical perspective on computers and technology. And I was told that like later on in the course we'll be working with coding.
Yes, you will.
And I've never really done coding before.
That's right.
So like in terms like, could you explain like what coding is, how it works? Because I've never heard it, never
Yeah,
done
most
it.
people have not done coding in this class, so that's the expectation.
Mhm.
And so it's sort of like what I was just explaining at the end of the lecture in terms of like giving the computer a recipe or instructions to do something, right? Maybe I'm just telling the computer to add 2 + 2 or something like that. So that's all the coding really is, and I'll kind of walk through like examples of that when we get to that part of the class. So to me, I guess the best thing for learning coding is just seeing a lot of examples and being able to refer to them. So we'll provide you resources for you to see examples. You'll be able to put them together like parts of a machine, like components, and you'll be able to produce what you need for your assignments, let's say. So we'll definitely get into that. But the long and short of it, to answer your question, I would think of coding as essentially like what I showed you at the end of the class today, a recipe to tell the computer to do something.
Yeah, of course. And in a little more of a personal question, like during your time here teaching at Rutgers, like would you say you've had a lot of students like struggle hardly with coding? Or do you think like, maybe they struggled a bit at first and they got around very used to it and they started doing much better?
I think it's more the latter, especially when we provide like the examples. So, everyone likes to have examples that they can refer to. And there's examples all over the internet for what we're doing. We're not trying to do hard coding at all. And like I said, 90% of the students that have come through almost any given semester on almost any given section of my classes, 90% of the students get a good grade, A or a B.
That makes me feel so much better.
Yeah. So, you just do the work and you'll do fine. 90% of more than 90% do very well in this class. this is not meant to be a hard class.
I came into this class thinking like I was so scared, like like people were telling me about coding, and I was just, I've never done it, and I have to take this class. It's such a requirement for business, and like
Yeah.
and like that now that I'm like having a talk about it in how what's expected, like it makes me feel a lot better. It makes me feel a lot much calmer. So I really do appreciate you, and I really do look forward to meeting you when
Yeah.
we get back to campus. And again, thank you so much. I look forward to working with you,
Yeah.
and hopefully I really do perform well in this class. And of course, if I ever have any questions or need any help, I would be hope you were more than happy for you to answer my questions. I will be sure to check your email,
Great.
and
Well,
yeah,
that's what we're here for. So we want you to do well in the class.
yeah, of course. And by the way, are you the TA or are you the actual professor? Because I saw someone named Mr. Professor Fuentes.
Yes.
Is he is he like the professor or like who's, I don't know really who's the professor and who's the TA?
Oh,
Um,
so yeah, so he's a professor teaching some different sections of this class. So I'm teaching
mhm,
sections 15 through 24.
okay.
And I guess he's must be teaching whatever sections 25 to whatever the number is. And then Professor Hajdu is teaching the asynchronous classes. So
Oh, so
there's three different professors for this class, and then there's like a ton of TAs.
okay. So you're going to be our main professor for this class, correct?
Yes, I'm the lecturer for this class.
Ah, okay, all right. Yeah. Well, I got no problem with that.
All right, cool.
All
Glad to hear
right.
that.
Yep. Thank you so much, Professor. Have a great night and take it easy.
All right, see you Thursday.
See you Thursday.
Cool.
Professor, I had a quick question.
Yes.
Where can I locate the PowerPoint slides on Canvas? Because I was looking during class trying to locate them and I wasn't able to find it.
Yeah, so if you click on my page
Okay.
where it says like whatever my sections are,
Mm.
if you scroll down to the table at the bottom, you'll see like I created a couple links there for both today's lecture as well as Thursday's lecture.
I'm sorry, what are you referring to?
Let me share my screen. Hold on a second.
All right, thank you.
Okay, so let me close this. Where am I at here? Let me just go back home. Yeah, so here 15 to 24, that's me.
Okay.
And then you can see down here, here's this table. I have the introduction lecture
Oh, okay, I see.
and the human computer interface here. It says PowerPoint. It's not really PowerPoint because we're not supposed to distribute the actual PowerPoint. So I converted the PowerPoint to Excel, not to Excel, to PDF.
Okay.
So you'll see it when you download it. I'll just click on it right now. And it'll ask you to save it to your local file system, and then you'll be able to pull it up as a PDF.
All right, thank you. Perfect.
Okay.
Have a nice day.
All right.
Oh,
See
rest
you
of your
Thursday.
day. See you then.
Cool.
Hi, Professor. I have a question.
Yes.
So there's a slight chance that I might take an asynchronous section due to timing conflicts. And
Yes.
I was wondering if it would be okay if I watched your lectures, or would that cause an issue with attendance and exam material?
No, it shouldn't. So you can take this, you can watch, or I don't know when we're going to go back to the class, hopefully after the end of the month. You can do that. We're teaching the same material across the three different major sections, right? Myself, Professor Hajdu, and Professor Guillermo. So it shouldn't be a problem. But I can talk to Professor Hajdu and let you know if there's going to be any issue with that.
Got it. Thank you so much. And also, you just mentioned that you're not allowed to distribute the PowerPoint slides, and I get that because I saw some footnotes while we were going through the lecture, and I was just wondering, like, do we have to know those footnotes and details through the book, or will we be okay with that?
No, you don't.
Okay, great.
So yeah, it's good.
And just my last question, in terms of people doing good in this class, you mentioned that like people do really well in your sections. So was that just in your section, or was that across all sections for new coders?
I would think that it should be similar, but I tell you the truth, I have never analyzed the other professors teaching, because the other thing is like, we rotate professors too, right? So not all of them have been teaching. So Professor Hatchfield has only been teaching for, I think, the last 2 semesters, maybe.
Got it.
So there's not that much of a track record that I can look at, right? I can only look at my own track record, which has been for like the last 3 years or so.
Got it. Got it. Okay. Thank you so much, Professor. Have a nice night.
All right, good night.
Bye-bye.
This has been quite informative, Professor. Thank you.
All right, cool.
Have a good night.
All right, see you Thursday.
See you.
Okay, I think the question's over. I was just staying to hear everyone's questions, stuff like that, because they could be helpful.
All right, cool.
All right,
So
thank you,
I guess-
Professor.
Yeah, I'll see you guys on Thursday then.
Of course.
All right. Hi, Shane, are you okay? All right, so Shane, I'll take it that you kind of left yourself on, so I'll close out this session and I'll see you on Thursday.